intermediate code generator. So how we can represent it? We can represent it in tree form, and we can represent it in linear form too. And there is further division for this form. In tree form, we can represent it in syntax tree, and we can represent it in DAG. And in linear form, we can represent it in postfix notation. And another way in which we can represent in linear form is 3 address code. So now we will take one example and we will see how we can represent it in different form. Suppose we are taking x is equal to a plus b into a plus b plus c. Suppose we are taking like this. So first we make the syntax tree for that. How we can make syntax tree? Let's see here. Because x, so we start with x is equal to. Now another thing is what? A plus b into a plus b plus c. So we'll make one here, a plus b, and make another one a plus b plus c. So we'll make another one a plus b and plus c. So a plus b plus c, a plus b. Now what we have to do? We have to multiply it. So we will take like this, and x is equal to a plus b plus multiplication a plus b plus c. So we will make like this. Now how many intermediate nodes are there? Number of intermediate nodes is equal to number of operator, that is, we need to count it, 1 2 3 4 5. How many? 5. Total 5. And number of leaf node is equal to number of operand, that is how many? 1 2 3 4 5 and 6. So this is the syntax tree, how we can represent. Now we come to DAG. How we can represent it? So we can say it didn't repeat the same thing. So we can use it in code optimization. So same thing as we can see here, we are using double time, or we can notate it like this also. As we have taken this, so we can break it like this. We can write it here like x is equal to a plus b into c. Suppose if we take like this, so another example I am taking. So first I'll take b into c, so t1 b into c, then t2. In t2 what we are doing? A plus b into c, so a plus t1. Then we are representing is equal to this, so you'll write x is equal to t2, like this. So we are taking this also, t1, we are supposing this t1 a plus b, this we are supposing T2 A plus B, and this T2 plus C we are supposing T3, and T1 into T3 we are supposing T4. So here DAG representation, if we talk, so we can write like this: X is equal to, here we can take A plus B, and because it is in both the things, so and plus C, so we are not repeating here, and here we are writing multiplication. So what we are doing here, we need to see here, we are doing like this and we are doing like this. So A plus B into, and this comes here, so we can say A plus B plus C into. So here we are not repeating this, so it means A plus B, and it means A plus B plus C. So that's what we want. So here we are not doing any repetition. So we can say number of leaf node is equal to 1, 2, 3, 4. 1, 2, 3 and 4. And number of intermediate nodes is equal to 4. 1, 2, 3 and 4. So in the similar way, we can represent postfix notation also, and 3 address code also, which we will see in the next lecture.